Beneath the hazy orange clouds of Saturn's moon, Titan, lies one of the solar system's greatest mysteries.
For decades, the surface of Titan was hidden from our view, until NASA found a way to cut through the haze and reveal. Our first close encounter with Titan came in the year 1979, when NASA sent a robotic spacecraft named Pioneer 11.
The data from Pioneer 11 confirms our hypothesis regarding the magnetic field at this intersection point near Titan.
We've known about the existence of Titan for centuries. It was officially discovered in 1655 by the Dutch astronomer Christian Huygens.
It's not hard to spot either, as you can probably tell by the name. Titan is big.
But it's still incredibly far away. So when Pioneer 11 first encountered Titan, scientists were eager to find out what it actually looked like.
But all that the probe was really able to see were the dense orange clouds that surrounded the moon. It was impenetrable. What Pioneer was able to do was investigate what that haze was made of, and it found something very intriguing.
This is very similar to what we have on Earth, and the majority of our own atmosphere is also nitrogen. Now, there was another familiar discovery made on Titan, and this is what really piqued the curiosity of scientists: hydrocarbons. What are those? Well, the technical answer is that they are carbon atoms bonded to hydrogen atoms.
On Titan, the atmosphere is filled with methane, which we generally know as natural gas.
Now, why is this important to NASA scientists? Well, a more practical explanation would be that in addition to being used, important molecules like DNA and protein are all built on hydrocarbon foundations. Here's a more familiar word for it.
So, if we can find oxygen on Titan, then we've got more than just the building blocks of life. We've also got the food to fuel that life.
Flying a probe close by Titan was also able to give us a sense of the moon's gravity.
For being so much bigger than our own moon, the force of gravity on Titan is actually a little bit weaker, meaning Titan isn't very dense, meaning it can't be made entirely of rock.
And that opens up some interesting possibilities. The combination of a thick atmosphere and weak gravity
Means that a person in a wingsuit could essentially jump off a cliff and fly like a bird for as long as they want.
It also makes a flying machine a perfect vehicle for exploring the surface.
Writing clearly is hard.
You write a line, read it back, and something just feels off.
That is where Quillbot's Chrome extension comes in. With one click, it can rephrase your sentence to sound smoother while keeping the same meaning. I find it particularly useful when sending emails.
So, say you're drafting an email to your boss or a client and you want to sound more professional. Highlight the sentence, hit Quillbot, and instantly see polished alternatives. Or maybe you're writing a school paper, a LinkedIn post, or even a cover letter. Either way, Quillbot helps you get your point across with clarity and confidence. The extension works right inside your browser, so you don't have to jump between apps or websites. Anywhere you're typing, Gmail, Google Docs.
And if you want to try it out, check the link in the description to install the Quillbot Chrome extension for free.
Once you start using it, you'll see how much easier it makes your writing, whether you're working on something technical, professional, or just day-to-day communication.
So this is what NASA found back in the 70s. A lot of very Earth-like ingredients hiding deep in the outer solar system.
See this faint arc here? I think it's a new moonlet.
It's small, but the shadow confirms it.
If this is accurate, the mass estimation shifts significantly.
They knew that beneath the clouds of Titan could be a discovery that would change everything we know about life and the universe. It was so close, yet so far away. They would have to wait for technology to catch up.
And 25 years later, in 2004, the Cassini spacecraft would finally arrive at Saturn to pick up where Pioneer 11 had left off.
This was a joint project between NASA, the European Space Agency, and the Italian Space Agency.
Cassini is equipped with the necessary radar and infrared scanners to see through the dense atmosphere of both Saturn and Titan.
Over the course of its 13-year mission, the spacecraft would fly past Titan 127 times, using its
What it found was mind-blowing.
Titan is the only moon in the solar system with an atmosphere, and this is a thick atmosphere, 4 times the density of Earth's.
So what that does is, it actually creates a reverse greenhouse effect, blocking out what little heat from the sun can actually reach this far.
So, as we move deeper towards the surface, all of the methane gas in the air gets colder and colder.
The average surface temperature on Titan is -179 degrees Celsius, and the freezing point of methane is -182 degrees.
So, it is the perfect environment to support a full hydrological cycle of evaporation and condensation, except with rocket fuel instead of water. In most places on Earth, rain happens pretty frequently because there's a lot of energy from the sun driving evaporation.
The result of which would be long periods of drought, lasting for hundreds of years, followed by torrential rainfall causing flash flooding.
So unfortunately, we did not visit Titan in its rainy season, but that doesn't mean that it was totally dry either.
As Cassini continued on its 13-year mission, the spacecraft continued observing Titan and learning about its surface.
What it found was that during the dry season, liquid methane is limited to the North Pole regions.
And what the probe learned to spot were these bright reflections of sunlight shining off the tops of watery lakes. This is the first body of liquid methane identified on Lacus.
Only the one on Titan is about 20% smaller, but it still covers about 15,000 square kilometers.
It's also an eerily still lake, with waves only reaching 3 millimeters in height. So to the naked eye, the surface would appear as flat and still as glass. Now, we're not sure why that is. Given the higher air pressure and lower gravity, waves should actually be bigger on Titan than they are on Earth.
And Lake Ontario has some pretty big waves.
Titan even has a small ocean at its North Pole. This body is known as Kraken Mare.
large enough that it actually experiences a tide from the gravitational pull of the nearby planet Saturn. With the liquid, although Kraken Mare is still relatively shallow for its size, around 300 meters deep on average, but lakes and oceans of methane are not the only active process still happening on Titan. There are volcanoes as well. Only we know that the surface of Titan doesn't have rock. It has ice that looks like rock, so the volcanoes don't erupt with magma. They erupt with slushy water.